Hello everybody and welcome back. We're going to be continuing on the Canadian Senior Mathematics Contest in this video. Where we last left off, we saw question number 4. It was a nice little question. We're going to move on to question number 5, which is more of a geometry-based question. It's going to involve moving around a square. Let's take a look. So, in the diagram, square PQRS has side length 25. Q is located at 0, 7. Okay, so here's the origin. Q has height 7 and it doesn't really go anywhere else along the x-axis. So already I'm beginning to suspect a 7, 24, 25 triangle. But we'll get into that in a little bit. The square is rotated clockwise about R, so R will be fixed and Q will sort of move up like this, P will move over like this, and S will move over sort of along an arc like that. It's rotated clockwise about R until S lies above the x-axis on the line with equation x equals 39. So until it's rotated around R until S hits this line. What are the new coordinates of P after this rotation? Okay, so after this rotation is applied, S will be leaning up against sort of this wall. Q will be off of this the y-axis wall, and P will be somewhere up here. We want to find the coordinates of P. Okay. So let's draw our scenario. We'll get ourselves a new piece of paper. That's pretty good. Not great, but it's pretty good. Okay. So that's what it's going to look like. How about we draw what it'll look like when it rotates? So, pen is not cooperating with me. So there's R, here's S, P, and Q, which we know, and here's the origin, and we know there's a distance of 7 here. This is 25. Alright, so let's draw what happens after our rotation. This is x equals 39. So R, wherever R is, we'll figure that out in a moment, stays the same. But now S is up here. Q has moved up there, and P, which is the one whose coordinates we want to find, is hanging up in the air. It might be past P, it might be past R, it might be directly above R, I have no idea. So there's P, and there's Q. And just for the full effect, how about using the navy blue, we just dash in what we used to have. So we've rotated. This is where it was. We rotated about R. And now this is where we're at. So the new S will have x coordinate 39. We know that for a fact. Alright. So it helped to know where our pivot point R is, the point about which we're rotating this square. So notice that triangle QOR, the one with the angle, the angle we're focusing on at the origin, QO is 7, and QR we know as a side of the triangle, or sorry, as a side of the square, is 25. So by Pythagoras' theorem, we know that OR squared is going to be QR squared minus QO squared. 25 squared minus 7 squared. It's one of those Pythagorean triples you should be used to by now. But you can work it out on your calculator. It's 24 squared. So OR is 24. And we know that R lies on the x-axis. So we can see that R has coordinates 24, and then it's got 0 height. Okay. But we don't really care about R. That's sort of a stepping stone. What we want is P. We want P up here. Okay, so how can we get P? Well, I think the best way to do it would be to label some new points. We'll have T over here. He's at 39, 0. And let's drop a perpendicular down here. And we'll call this point U. And he'll be at 39, U. Okay? So why did I do that? Well, I want to try and find P, and we already used one right angle triangle, so I notice here that RS, that's still going to have length 25, and I can tell the difference, the distance RT. You know, we know that this whole gap is 39, and that R comes 24 units all the way over. So we're going to have 15 left over. We're going to be able to figure out the distance ST. So that's why we put T in there. We want to talk about triangle RST. Now, why did I add in U? Well, I'm thinking ahead. I'm thinking how best to get P. We don't exactly know where he is. If he's directly opposite R, we could figure out the diagonal of the square and add that to we add that to the y coordinate of R. But we don't know that P lies above R. It could be back over here. It could be over here. But what we can do is, using RST, we can pretty easily figure out the coordinates of S. Then if we had SPU, that's another right angle triangle with length 25 as the hypotenuse, we might be able to get something done. It's just an idea, that's why it's marked in red. It's nothing solid, we're just experimenting. But I'm pretty sure this is the best way to go about the question. So RTS is also right-angled. So TS squared is going to be equal to RS squared minus RT squared. Well, that's 25 squared minus, and then we do 39. That's the x-coordinate of T minus the x-coordinate of R. Because they lie on the same x-axis, we can just subtract coordinates there. So that's 25 squared minus 15 squared. So that's going to be 20 squared. That's another one. That's sort of the 3, 4, 5 triangle, which is another common Pythagorean triangle. So this question seems to very much be about Pythagorean triangles, Pythagorean triples, right angle triangles. which is why I'm ever more confident in our placement of U up here. So we may have to go back to that page to refer to our diagram, but knowing what ST is, so S has coordinates. Well, he's 39 for his X coordinate. We know that. We rotated until S was lying on the line X equals 39. But now we know how high up he is. He is going to be 20 units above T. Well, T has Y coordinate 0. So we're looking at 3920 for S. So we have another right triangle at PUS. Problem is, the Pythagorean theorem is not going to help us here. Okay, we don't have two of the side lengths with which to get the other side length. We really don't. All we know is that we have length 25 here. But I noticed that TSU, that lies on a line. I know what this angle is. This is 90 degrees. And I know that these two angles will then have to sum up to the full 180 minus 90 degrees. So we can get sort of a similar triangle thing going on. It's odd to write the angle of a line, but you really can. So we have RST plus RSP. Oops, I should have an angle sign there. And finally, angle PSU. So we know that the other two angles here add up to 90 degrees. So we could say that this one here, RST, is X. This one down here is going to be 90 minus X. This one in here has to be 90 minus X. That means this one up here is going to be X. Okay, so it's not hard to see that PUS and STR are similar. In fact, since they share a side length, they're congruent. So PS equal to SR. RST is equal to, what's the other one? It's SPU. RTS is equal to, so here we're doing the 90-degree angle. And lastly, SRT is PSU. Then we know that triangle RTS is congruent. So that means they're the exact same triangle. They've just been translated and rotated a little bit to, let's make sure I get the values right, SUP. Okay. So what does that tell us? Well, then that tells us these other two lengths here. Right? It tells us the length SU is going to be the same as RT. Well, we know what that is. That's 15. Tells us that UP is going to be the same as ST. Well, we figured that out. That's 20. So what have we got here? We have RT is equal to SU is equal to 15. And TS is equal to UP is equal to 20. So what's the coordinates of U? Well, it's going to be 39. And then we're going to add on 20 to the y coordinate of S. Or sorry, we're going to add on 15. So it's going to be at 35. How do we figure out P? Well, from U, we just come back to the left. So we subtract off this distance, 20. Okay. That's really our final answer right there. We don't need a therefore statement. We already have our little statement. P is at 1935. It's up the same height as U. Okay. So this distance here, that's 20 and that's 15. So it's up 35. And then we come back the distance ST. Well, what was ST? That's 20. Come back that distance. So 39 minus 20, that's 19. So P is at 1935. So a nice little right angle triangle question, but they threw us a bit of a curve there at the very end. We couldn't just keep using the Pythagorean theorem over and over again. We had to think for a moment and identify not similar, but congruent triangles. So it was a sort of a two-part question, doing the Pythagorean stuff and then the similar triangles. But it didn't take us that long, even longer if you weren't writing out all your explanations for everything. Remember, these questions are only worth 5 marks in this part, so don't go overboard with your explanations here. And that about wraps up question 5. In the next video, we'll do question 6, which will be the end of part A. So thanks for watching as always.